Sieve mesh, what does it look like? Test sieves are used in a variety of industries to determine the distribution of particle sizes in raw materials, processing stages, and finished products. Materials for highway construction are at one end of the requirements. These openings are measured in inches. At the other extreme are pharmaceutical applications that top out at less than 5 microns. In between are just over 50 standard test sieve sizes. The range of openings is achieved by different weave sizes of wire mesh. The largest standard is a mesh with 5-inch openings. That's pretty big. Substantial sized rocks will pass through these openings. To give a perspective on the look of these mesh sizes, we photographed a few, comparing them with common items. Our objective is to give a frame of reference by relating the opening sizes to real-life material. We start with a 50 millimeter or 2-inch sieve using a dollar bill and a pen for reference. We make a jump to 6.3 millimeters or a 1/4 inch, comparing the opening with a couple of quarters. When the hole sizes get smaller, the numbering convention changes to an alternate number starting at 3.5 for a 5.6 millimeter sieve and ending with the number 635 for a 20 micron sieve. Yes, the number increases as the size decreases. By the way, a 20 micron sieve is at the limit of woven wire mesh potential. The producers of gravel for the construction industry use sizes that range from larger openings, such as 3 inches, to the level of 1/2 inch. Moving on to the soil sampling analysis, soil sampling specifications regularly call for sieve ranges from 2.8 millimeters, a number 17, to 1 millimeter, a number 18. As the sizes get smaller, for example, a 710 micron, 125 number sieve, a small sewing needle will pass through an opening, but a push tack will not. At the level of a 425 micron sieve, or a number 40, only the point of the needle will fit into the holes in the mesh. Next, we test some sugar using 3 mesh sizes: 355 microns, 250 microns, and 180 microns. We find that all the sugar goes through the number 45 or 355 micron sieve. Some of it passed through the number 60 or 250 micron sieve, while some stayed on the surface. None of the sugar that went through the 60 sieve passed through the holes in the number 80 sieve. These results tell us that sugar particles were all smaller than 355 microns, that some were larger than the 250 microns, and that none were smaller than the 180 microns. So the range of the sugar particles were between 180 microns and 355 microns. I'm sure that many of you are familiar with coffee creamer, the artificial cream for coffee. For our next illustration, we loaded a scoop of creamer on a 120 micron sieve and shook it through. All of it passed. At the next sieve, a 106 micron sieve, most of the creamer passed, with a small amount being retained, some particles larger than a 106 micron, but smaller than 120 micron. At the 75 micron sieve level, almost no creamer passed through, telling us that the remaining creamer consisted of particles larger than 75 microns. Next, we observed a ruler and paperclip behind a 45 micron number 325 sieve. As you can see, there's only a faint shadow. The mesh almost completely stops the light. Sieves with opening sizes less than 45 microns, namely a number 400, 38 micron, a number 450, 32 micron, a number 500, 25 micron, and a number 635, 20 micron sieve usually requires special processes such as vacuum or ultrasonic assists to get effective separation. We hope this short film gives some perspective on the range of opening sizes available for wire mesh test sieves. Please use it for staff training or forward to a colleague. Thank you for watching.